Hello, I'm Matthew Hine, Chief Product Officer at RDX Works. I'm here today to talk about a new feature coming to the Radix Network and the Radix Wallet that we're calling pre-authorizations. I want to record this video particularly for our developer audience, but I think others might be interested as well, to talk about pre-authorizations because I think it's going to be really exciting for what dApps can do in the Radix ecosystem, and it's also going to be one of the critical enablers for what we're doing with Anthic and Project Flow to bring institutional capital to the Radix network. So I wanted to record something that was a little bit unrehearsed off the cuff to talk about pre-authorizations as early as I possibly could, because I do want to get our developer community and you guys thinking about what you can do with this capability, what new things you can do with your dApp using pre-authorizations, because I think there's actually a lot of really cool stuff. This is something that we're working on now that it's been on our roadmap backlog for a little while, but now is the right time to pick it off because it did help us out with Project Flow and also I think was going to solve a number of problems that we're hearing from the community that they're having for application building. So anyway, I want to go through here. This isn't a formal presentation, but I want to just give you our design thinking. This is a little bit preliminary, but it's pretty close to, I think, how everything's going to work. And we can give you a bit of a sneak peek of this so you can start thinking about your applications. So let's dive in. What I want to talk about is how pre-authorizations are how they're different from today's transactions. It's a related concept of transactions, but it's a little bit different. I'm going to talk about how dApps can use them with the Radix wallet. So if you're a dApp developer, how you're going to be able to make use of these things with the wallet. Some interesting use cases that pre-authorizations are going to enable, and also show you a preview of how pre-authorizations are going to be presented at a UI level in the Radix wallet. So you'll be happy to know this is not a slide deck presentation. I just kind of have some little things that I put together here that I want to run through. So let's start with this. So if you're a developer, particularly if you're a Radix front-end developer, this is something that's going to be at least somewhat familiar to you. I'm calling it the manifest stub model, but basically speaking, this is how you build a transaction with the user's Radix wallet and get it submitted to the network. And the stub model, this is a simplified version of it, but it'll get the point across. Basically, the stub model works like this in today's model. So for simple transactions today, your dApp is going to build a transaction manifest stub. It's not a complete transaction, but it's a stub that describes most of the stuff that you want to have happen. And then this gets combined with some manifest commands that get added by the Radix wallet in the user's Radix wallet. And this happens automatically. The Radix wallet just kind of knows what things to add for guarantees and things like that. So basically, those things get combined and become the final transaction manifest, which gets combined with some signatures and a notary and some things like that. Ultimately, that becomes a real transaction that you submit to the network. And you can think of that transaction manifest as having this little context where you've got buckets that you can pass around between things you're calling in the manifest, and you've got you can do some authorization, so you can check for badges that are proofs of badges that are present for that transaction. So this is how it works today. What we're doing with pre-authorizations is basically expanding this capability. This model still remains the case. Everything here will still continue to work just as it does today, and this is going to work for a large number of example use cases. But we are adding something pretty interesting called pre-authorizations, and you can think of it as a new option that we're adding to the transaction model. It's a new capability that you'll be able to do within how transaction manifests work. And the idea is this. At a high level, the idea is we want to enable the idea of a transaction which isn't just reviewed and signed and submitted by one party, which is how it works today. Even though we technically have multi-signature and that kind of stuff in the network, right now you kind of have to you'd have one party that kind of needs to collect everything. So it doesn't really do all that much unless you're doing some kind of back-end system stuff. But basically, what we want to do is allow multiple parties to work together to collaboratively build a transaction. And the reason why you'd want to do that is that different parties may be able to authorize different parts of the transaction. Alice can sign for her account, Bob can sign for her account, and maybe there's some application that can sign for an ability to call some component or something like that. So there are a bunch of use cases, which I'll get to later, where you want to be able to do this multi-party transaction building stuff. A lot of ways of going about it, but this is one particular form of it, which is really interesting, we think. But in the end, the idea here is that whereas before we just had a single manifest that was being signed and submitted, now what you can do is break the manifest into these sub-transactions or subintents. So when you hear me talk about intent, it's really the same thing. Basically, an intent is a manifest that's been signed and has some headers and that kind of stuff. So the idea here is you could have these different parts where there's always a parent, which is sort of the coordinator for everything. And that parent can then call multiple children. I show 2 of them here, but it could be 1, it could be 15. So you can have these child, and each one of those children has its own little transaction manifest, which I'm calling a sub-transaction manifest. And each one of those things has its own little context. It can pass buckets around between things, it can check for proofs when that thing, but they are fundamentally quite separate. Of course, we want these things to be able to work together, and so the way we do this is that we can yield buckets back and forth. You can kind of think of it as basically each little part of the manifest can pass a bucket across to another child, and the child can pass a bucket back up to the parent. So this becomes, it very much follows our asset-oriented model and lets you do some very cool stuff. And within that model, what we allow is that now you can have a sub-transaction manifest stub, very similar to our current transaction manifest stub, that could be proposed by a dApp, and that manifest commands could be added by a Radix Wallet and become a final sub-transaction manifest. And now we can combine together multiple instances of that to build much more interesting transactions across parties. Okay. So that's the basic technical capability, and I wanted to start with that so you had this in mind. Just imagine this idea that you have different parts of the transaction that are passing buckets around between them and different parties that are signing for those different things. But the thing I want to go to next is from a developer's point of view. If you're building an application, what does this mean for you? Like if you're requesting, when do you request one of these versus one of the old style of transaction? What does this mean? So I'm going to go down here to the dApp to wallet request types. So once again, if you're used to using like Radix dApp toolkit with your front end, you can make requests to the Radix wallet. And one of those request types is a transaction request. So you can build a manifest stub, pass that across the wallet will do some things, and we'll submit that to the network. So that is exactly what the current model looks like. So just to give you a little diagram of this, your dApp front end in particular is going to build a transaction manifest stub. I'm calling it a main manifest stub. It doesn't matter, basically just building that stub, passing it to the wallet. That dotted line is we have a particular interface. So we have some rules for what types of stubs you can propose to the wallet and that sort of thing. And then once the Radix wallet receives that, it can add things like a fee lock, it can add guarantees. Once we get to multi-factor, we'll have access controllers here as well that will implement multi-factor signing. And then ultimately you apply some signatures from that wallet, which makes that transaction valid. And once you do that, you submit that to the network. That's how it works today. And again, none of this changes. We can keep doing this in the new model. However, we're adding something new. We have a new request type that we're calling a pre-authorization request. And it works in some ways similarly, but in some ways quite different. The idea here is that now the dApp is building sub-transaction stubs, like I talked about above. And it can potentially pass these to even multiple wallets. So I'm showing 2 here. It could be 1, it could be many, depending on the application. But you can pass those transaction manifest stubs to the wallet. Similarly, the wallet is still going to present this to the user, and the wallet can add some things onto that manifest stub. One thing you don't see there is fees, and you'll understand why that is in a little bit. But it can still do the other kinds of things, including guarantees. Guarantees, there's an asterisk on that. But basically, you're going to present, the wallet will present that, will sign that sub transaction, and will pass it back to the dApp. And that's quite different than today. Today, anything proposed to the wallet is submitted to the network by the wallet. The wallet's fully in control. In this case, we have to allow the wallet to pass it back to the dApp because the dApp is the one that needs to basically combine together these different subintents to be able to do something interesting. So maybe it's combining together sub transactions for multiple wallets. Maybe it's building its own parent transaction to do some sort of special coordination, and it's combining that with a sub transaction that you signed. So basically, it's like the dApp is saying, here's the part of this that you care about, that you need to sign. You're going to sign only the part that really matters to you and your assets. And then I'm going to maybe combine that with some other things. And ultimately that becomes a transaction that I, the dApp, am going to submit to the Radix network, not the wallet. We'll talk about how that works in a minute, but this is the basic model. And this provides a whole lot of power for applications, because now applications can sort of act in this coordinator role to combine things from multiple parties and different applications, backend systems, whatever you want to do to build up a transaction and get different authorizations from different people. And this enables some really interesting use cases. I won't mention them right now because I'm actually going to show you what those different use cases look like in a minute. But before I show you that, I want to give you kind of a more tangible view. Actually, you know what I do want to do those transactions. I'll show you I'm going to show you the wallet experience, but I want to do one of the example use cases first. So let's go down to those use cases. What can you use this for? If we have this way of getting sub-transactions signed by users and combining them together, what does that enable? There's a bunch of different things, but I picked off a few little use cases here that I think are particularly interesting. The first one is Anthic. So those of you that have been following our recent blog post, you've read about how Anthic is something we're working on, which is called an intent-based DEX. Or really, Anthic is sort of a backend system which enables DEXs and enables other DEXs on the Radix ecosystem to make use of this. But to kind of prevent a simplified view, you can kind of think of it as a DEX. But the idea is we want a DEX that's not using an automated market maker, but basically is bringing together user orders and market makers' capability of providing liquidity and bring those things together to be able to enable trades. This is something that's kind of done on Ethereum with CowSwap that's doing intent-based trading. And we're doing if you read the blogs, we're doing some very cool stuff with this with Anthic and in terms of like flash liquidity and so forth. But that doesn't matter here. What I want to get to is just the core of doing this intent-based order. So the way it works is this. Here are our three different sub-transactions that are going to be combined together into one overall transaction. There's a parent. And the parent is created by the Anthic off-ledger solver, we call it. So the Anthic system itself has this bit of logic, which is going to be sort of the coordinator that's going to combine things together. So it creates this parent, and then there are two different child sub-transactions, which it's going to be combining together. One of them is from the taker, the person who's trying to get the trade done. And one of them is from the market maker, who's going to provide the liquidity to make that trade possible. And what we need to do is combine those things together into one atomic transaction. So it works like this. The parent execution, like if you imagine these whole things are being combined together and submitted to the Radix network, the execution starts with the parent. So the first thing that happens is a lock fee. Again, this is high level. Like if those of you who've built transaction manifests, you know there's a lot of details here, but this gives you an idea. So first command of the manifest is locking the fee. Parent always does that. And this is an important point. In this sub-transaction model, that parent, which is pretty much the dApp, is always going to pay these fees because it kind of has to. It's basically getting signatures from a bunch of people, but ultimately it's the one that's going to submit it to the network. So it's the one that has to choose how much fee to lock and make sure that gets done. And I think it makes sense. So the parent, which is again, the dApp, the Anthic system basically is going to lock the fee from its own account, let's say. And then right after that, it's going to do this thing called yield to child. And basically what that means is I'm passing the baton over to this sub-transaction. And now it can start executing. And so it would identify it saying child A can now start. So now I jump over to this sub-transaction. It starts executing. First thing it does is withdraw some USDC. And then it yields to the parent, and it yields those transactions, those resources in a bucket back to the parent. So it passes that bucket back to the parent in that yield statement. So you've got 5,200 XUSDC, which gets yielded back to the parent. Now this is in the worktop of the parent. Now you go down to the next step, which is to yield to child B, but this time it's going to yield with that bucket that it got from child A. So now we jump over here. Now we have that bucket of XUSDC in child B, and child B is going to deposit that to its account. So this is the market maker now. So the market maker is going, okay, I'm going to take your USDC. I'm going to put that in my account. And now I'm going to withdraw some of it, like sort of the correct amount of XETH tokens. Basically, this is like the order that it's willing to fill on this at the rate that it's willing to fill based on market pricing. It says, oh, for 5,200 XUSDC, I'll give you 2.034 ETH. And it would then pass that bucket of XETH back to the parent again. Now with that bucket in the parent, it can then pass that once again down to child A. So now child A picks up where it left off. Now it's got that bucket and it can deposit that to the account. Now, when the user signed this one, what they saw was this stuff only. They saw, okay, what I'm going to do is I'm going to be withdrawing 5,200 XUSDC, and in the end, I'm going to deposit a minimum of 2. I don't know exactly what the market price would be, but I know that right now it should be at least minimum. So there's a guarantee in here that says I'm going to get a minimum of 2 XETH back. Well, as it turns out, I'm going to get a bucket of 2.034, so that's going to be satisfied, so this is fine. So I, as the user in the Radix wallet, I'm going to sign this. You'll see what that looks like in a minute. And then I would yield that back to the parent. Transaction is done. So this is very cool because the ability to get the XUSDC and the ability to deposit the result in my account is signed by me in my wallet. The ability of pulling these tokens out of this account and providing XETH is signed by the market maker, who has the rights to their own accounts. And we can combine those two things together, and we're guaranteed that both of us will be satisfied. If I don't get at least 2 XETH back, this doesn't going to work for me. You can't use my sub transaction. The market maker, it's like, hey, if this is the thing I'm willing to do, as long as you're willing to pass me this much XUSDC, if you pass me less than that, then that deposit's going to fail and the whole thing is off again. So it's this cool thing where both of us can independently sign our parts of the transaction, but we're guaranteed to get what we want. And we kind of don't care how it happens. When I'm signing this trade order, it could be any market maker. It could even be an AMM. It could be any number of things. It could be a different user's order. Somehow I'm just saying, like, as long as you give me what I want, I'm good with this. I'm willing to sign. And the market maker basically does the same thing. And now we've got this solver application, which runs off ledger, which basically pulls these things together. It goes, oh, I can match that order with this market maker, and cool, I can submit that to the network. Everybody's happy. This is super, super powerful. And this is going to be built right into the transaction model. And again, unlike the Ethereum way of doing this, it's going to be done in a very asset-oriented way. We're going to have buckets being explicitly passed and forth, and we've got guarantees and all those sorts of really nice things that we have in the manifest model. Okay, this is probably like one of the more complicated examples, but I want to do it first because it is really powerful and it's one of the main things that we're really focused on right now. However, there's a bunch of other really nice stuff you can do when you have this capability. So let me go through a couple of other examples. One of them is delegated fees. This is something that we've been talking about for a while, and the network itself, and actually even the Radix Wallet, has delegated fee capability right now in a way, but it's quite limited the way it works right now, to be honest. And so we've had a number of developers who are like, oh, cool, I really want to build an application where if the user is using my app, then I'm willing to pay the fees on their behalf. And we have to say, well, technically it's not that easy, because the way it works right now, I won't go into it, but basically if you try to pay for fees, but you're giving the user full control over signing and submitting the transaction, well, basically you have to trust the user to only do the right thing. And basically what that means is that someone can take advantage of you and run off with all your XRD tokens by just kind of draining your fee payment account. So it doesn't work unless you're in some very narrow circumstances right today. But this gives you, if you're thinking about delegated fees, this is what you were imagining, and it works basically the way you expect it to. The way you would do this is that rather than submitting the transaction, let's say you're building a transaction for one of your users and you want to pay the fee for them, rather than building them an actual transaction stub, this time you'd build them a sub-transaction stub. You'd build them a pre-authorization. So you would send a pre-authorization request that does whatever stuff you want to do, whether it's a DEX swap or anything you wanted to enable. It could be staking to your validator. You can do whatever you want. But what you do is there's an assert worktop is empty command you put at the front, which basically means like nothing's being passed into this. And then you've got a yield to parent, which doesn't yield anything back. It basically kind of like seals this subintent off. You're not passing any buckets in and out of it. And so the user knows exactly what's going to happen. They can look at that subintent and basically we can show it to them just like a regular transaction. But when they sign it, they're passing it back to you. And your application can observe that subintent and go, okay, I see what you've signed here. Yep, that is actually what I want you to do. That is what I want to pay the fee for. And now your application can wrap it in a parent, which locks the fee. And all you do is you lock the fee, you pass the transaction over the subintent, and that's all that happens. This is really nice. And in fact, as you'll see in a moment, the user will get this nice sub-authorization experience where they'll be told, hey, you don't have to worry about the fees for this thing. Here's what you're authorizing. Here's what's going to happen, but don't worry about the fees. dApp will take care of it for you. This is what you want to do. In fact, like if we had this already, I would have used this for RadQuest and other things we've done. Use this for the Gumball Club. So there's a lot. This is going to be a really, really nice model for all those times where you want people to be able to do things, but you don't necessarily want them to have some XRD on their own already. So actually, with that, let me go down to the user experience because this will give you a more tangible idea. What does it look like for the user when they get a pre-authorization request? And here is a preliminary wallet UI. Some of the details in this may still change, but this is probably pretty close to the way it's going to work on the wallet. So when you send a pre-authorization request to the wallet, you're going to get an experience which is pretty similar to what you get in the wallet with the transaction request today. So right now, what it says at the top is review your pre-authorization instead of review your transaction. That's fine. And pre-authorization, the reason we use that term is it kind of sets this expectation for the user. It's like, look, you're going to be signing something where you're authorizing that this thing can happen. But you're not going to be the one submitting it to the network. You're just saying, this is okay. If this happens, this is fine with me. And then you're going to be passing it back to the dApp. So looking at this top to bottom, you would see that the pre-authorization was proposed by, let's say, Megaswap. Let's imagine this is some DEX that you're doing something with. And you would see the normal sorts of things you would see. Now, the presentation is a little bit different here. We don't do the jaggy-edged thing because we're kind of trying to put the pre-authorization in this particular bubble. But basically, you're going to see things that you're used to, like, this is going to include withdrawing from my account. So there's an amount of XRD that I'm going to withdraw from my account. Obviously, I'm going to have to sign to make that possible. Then in the middle of this, I'm going to be using the Megaswap dApp. So maybe you're making an explicit call to a component that's associated with Megaswap in the transaction. We also put this bubble in here that says possible dApp calls. That just kind of indicates to the user that, something could happen where you're going to be there could be other components that get called outside of this pre-authorization, but you don't really need to worry about it. It's not like it can do anything unpredictable with your stuff, your assets in your accounts, but there may be other dApps involved. And then ultimately, the other thing you care about is going to be the deposit at the end. So if this is a swap, you'd see like, all right, I know I'm going to get a minimum of this many tokens at the end of this transaction. Cool. So this feels pretty familiar, actually. I'm providing this amount of XRD. Here's the result I expect to get back. Great. And now at the bottom, we have a little indication that says, hey, this pre-authorization will be returned to Megaswap for processing, and the network fees will be paid for by that dApp. So you don't have to worry about that fees. We don't show anything about fees here because you don't have to worry about it. And Megaswap is going to be the one responsible for kind of taking it from here. It's kind of like handing your credit card to the waiter at a restaurant. You're kind of saying like, here, I'm authorizing you to run my card for $25, and they go and they do it for you. You'll also see this is a different element here where pre-authorizations, because you're providing it back to the dApp, there's always a time frame that we put on that basically says, I'm giving a pre-authorization, but hey, dApp, it's only good for a limited amount of time. You don't just get to sit on this forever and submit it at some point in the future. So for example, it might be like, look, this pre-authorization, I want to do this DEX swap. This is only valid for the next 60 seconds. Either you do it within the next minute or you can't use this. My pre-authorization is no longer good. So we show that to you very clearly. And then once you're done, you just, very similar today, you slide to sign and return. So when you sign this, it'll gather the signatures just like today, and then it'll pass this signed pre-authorization, the signed subintent, back to the dApp, and then it can process it. And in fact, I don't show it here, but in fact now the wallet can still watch the network to see if it processes. So even though the dApp is responsible, if the dApp uses your subintent, the wallet will be able to pick that up from the network and say, I can see it was used. Here's the transaction. And it'll be able to show you the normal progress indication of like, yep, it's processing and now it's done. Most dApps will tend to want to do this very quickly. So the user experience is very similar. You slide to sign and return, you move on to a little progress screen, and then the transaction finishes. So it feels very familiar. So for example, if you wanted to pay delegated fees for your users, they're going to have experience that's going to be just as friendly as what they get with regular old vanilla transactions today. So pretty excited about that, actually. I'll do another couple of use cases here just real quickly, just to give you another idea of some other neat stuff you can do. Another one is this. So user badge depositing. This is one that's been kind of bothering us for a little while. So we've been talking a lot about this claim pattern for developers. Like, look, if you're trying to get things to users, get tokens to users, don't just try to deposit directly to their account because they might have disabled deposits to their account. And so you might cause all these bits of confusion. Also, a user might want to change what account they're using. So it's kind of bad to just really focus on like, oh, you user, you are this account. So we encourage you to use this badge pattern where if you have a known user, you provide them with a unique user badge, maybe make it non-transferable, and then they can present that badge in transactions to claim things from your application. This is a much nicer pattern. It's a more asset-oriented pattern. It works out really nicely. However, it's actually a little bit tricky to do that first step of how do you get the user badge to the user? And we've proposed some possible patterns for this. You know, you can try doing that one deposit on its own. You can do something where you have a claim where you kind of check the account owner, but it's honestly a little bit hacky doing it today, which is unfortunate because we do really want this pattern to be very common. And so having that first step be a little bit tricky for the dApp developer to do right is unfortunate. This is what we had to do on RadQuest too. We had to do this kind of slightly hokey thing of getting you the hero badge. But pre-authorizations make this really nice. And in fact, the user doesn't even have to have any XRD. You can just get them their user badge. And the way you do that is you propose to their wallet a sub-transaction, a pre-authorization request, and all of that pre-authorization request says, deposit a dApp badge to your account. So dApp badge being the badge that you're creating from your system. You know that you have a certain resource that you're using for doing this. So basically the user will see a nice preview that goes, oh, I'm going to deposit, Megaswap's user badge to my account. I don't know what the local ID, I don't know what the exact ID is, but I know one of those badges is going to be deposited to my account. User goes, yeah, I want that to happen, of course. So I'll sign that transaction and I'll pass that back to the dApp. Very simple from their point of view. Now your system, your dApp system off ledger can look at that and say, okay, I can see that the user has signed a pre-authorization, which is depositing the badge to the correct account. So for example, if that user logged in with a persona to your dApp front end and they shared an account with you, and maybe they even provided roll-up proof that they are the owner of that account, now your off-ledger system goes, cool, I know who you are, I know what account you own, I want to put a user badge in that account. Well, you can build this subintent, build this pre-authorization, and you can make sure that pre-authorization when it's signed actually does the thing you want. It goes to the correct account. And then all you need to do is lock the fee, mint the badge, and then pass it to the child. Actually, I didn't show that in you. I messed this up. There's supposed to be a command in here. There should be a command in here to mint the badge from your system, and then you can yield that badge to that subintent, and then it'll be deposited. Super easy. So this, I think, is going to be the right pattern for doing this user badge. Basically, like as soon as the user logs in with their persona, just build them one of these little intents to deposit a badge to their account. And then you can mint that badge, push it to their account. They didn't have to pay any fees, and you've got absolute confidence that it got there. It doesn't matter if they had any deposit settings set on their account because they're signing the transaction to deposit it. So it goes around all those settings. So very, very handy. The last one I'll do, because this is a classic, is the basketball ticket. This is a little bit tricky also. I won't maybe go into this full depth because this video is getting long. But if you go back to the old RadFi video from a while back, and one of the things we showed in this RadFi video is like, hey, in the future, we're going to be able to do this thing where Russ and Matt can buy tickets next to each other at the Mavs game, and they can do that atomically, where we make sure that both Russ and Matt buy the ticket or neither one of them do. We don't want to have the situation where, well, the order was processing, Matt submitted a transaction, his went through, but then actually Russ's ticket got sold in the meantime, and now Matt's stuck with a ticket he doesn't want. It's annoying. So we can do that with pre-authorizations. Very, very cool. And basically the way we do it is the ticketing system acts as the coordinator, and it builds separate sub-transactions, I keep saying this, separate pre-authorizations from the point of view of the user, builds separate pre-authorizations, sends those to our wallets. So basically, let's say it's Alice and Bob. Alice sees a pre-authorization that's basically saying, yep, I am going to get this particular seat. I'm going to get seat 15A as an NFT, and I'm going to pay this amount of USDC in order to do that. And same thing, Bob seems the same thing. I'm going to get 15B and I'm going to pay some USDC to be able to do that. Obviously, Alice and Bob want those things to happen, and the ticketing system can basically tell them, they can put a little message in there, but it goes, hey, so what we're going to do is make sure that Alice and Bob get these seats. Alice, you're going to get 15A, Bob, you're going to get 15B, and both of them can see that in the message field in their wallet, and they know, cool, that's what I want. And now the ticketing system has the tools they need to make sure that's atomic. if they don't have to like make sure that they're locking their ticket system to make sure they can process it. They can just throw the transaction together that uses both these subintents, basically mints the NFTs for 15A and 15B, passes those to those different subintents, and if everything worked, the whole thing goes through and they deposit the USDC to their own account. If something happened, let's say that in the meantime, some other transaction consumed seat 15B, and therefore that one can't be minted because it's already been minted, then the whole thing fails. Then the ticketing system submitted that transaction, network rejects it, and the whole thing is atomically rejected. So this makes it much simpler for the dApp to build these sorts of things where you don't have to have a bunch of like complicated coordinating logic to make sure that these sorts of things are atomic. This is like the train and hotel problem thing from way back, if you're familiar with that classic from Ethereum. So that's the overview. We're really excited about this. Pre-authorization is going to be really cool. I think, what you can see is that from the user's point of view, this is still going to be, it's still holding to all the things that are important about the Radix Wallet experience. They still get clear confidence in what's going to happen. And they still get this nice model of interaction. And from a dApp developer point of view, you now have some really powerful new tools to be able to delegate fees for users when they're coming into your system for the first time, give them user badges, and do interesting things coordinating between transactions between multiple users and between maybe your backend system. So we're really excited to think for you guys to start thinking about what use cases you can do with this. Certainly really interested in starting to answer questions about how this is going to work. As I said, we've got a pretty good idea of the functioning of this, and now it's just we're doing the work of this is going to be a protocol update to the Radix network to build this capability into the transaction model, and obviously it's going to be an update to the Radix Wallet and Radix dApp toolkit to enable this sort of stuff. So we're actively working on that right now. In the meantime, we'd love to talk to you guys about it. So thanks very much, and we'll see you in the community.